Hello guys, we are the Calculads. I'm Eric, this is Mason by the camera, and Mohammed decided not to show up. So today we'll be talking about higher order derivatives. So right here in this chart we have the notations for y, f of x, and the y in a different form. So for the first derivative of y, we can call this y prime, where there's just one like apostrophe looking line above it. For the second derivative of y, we call this y double prime. This one would be called y triple prime, and for the nth derivative, we would call this y to the power of n. For the f of x, f prime of x, and then so forth, where this is f triple prime of x. And for y, where it's dy over dx, d2y over dx squared, and so forth. So for our first example here, we have given f of x equals x to the power of 6 minus 2x to the fourth plus 5x squared minus 3x plus 9. And we know that with the power rule, to find the first derivative, and we know that this is the first derivative due to the notation of f prime of x. So we know to find the derivative of this entire function here. So knowing that the power rule says to bring the exponent down to the front, and then afterwards you take one off of the power. So the first part here, x to the 6th would become 6x to the 5th, and for the next part, we have 2x to the 4th. So we would multiply 2 and 4 to get 8 here, and then 4 minus 1 would equal 3, and we keep the negative sign. And then all the way down, where right here we have negative 3x, and since we know that we have to remove one of the 1 power of x in the very end, so that just remains to the whole number of negative 3. And so far, we have gone through the first prime. For the second and third, the higher power derivatives, all you really do is that after you find one, you just find the next. You just do the same power or same formula with the power rule. And for here, where we have 6x to the 5th, multiply 6 and 5, you get 30, and then 5 minus 1 equals 4. And then the same for this and this, you get here. And for the third derivative, you do the same thing. So as you see, it slowly goes down by one term, because one term is being cut off every time, because using the power rule, we know that this is no longer existent in the next derivative. So for our second example, we have d over dx of x to the third plus y squared equals negative y. And using the same process as we did before, we can come to 3x squared plus 2y dy over dx equals negative 1 dy dx. And after we continue the process, we know that with the chain rule, we have to substitute this into dy dx here. And where these little two blue x's are, we have to replace that with what we have here, which is negative 3x squared over 2y plus 1. And the reason that this becomes this is that using the quotient rule, we know that we have to find a different form of this and not just simply divide them after we find the derivative. And simplifying this with the dy dx that we plug in, this is our final answer in the purple. And that is all. Thank you. Bye-bye.